Welcome to Microscopic Marvels.
Today we're going to look at one of the most fascinating microscopic marvels there is, the incredibly complex electrical world that's buzzing inside our own heads. For the longest time, we thought of depression as this invisible struggle, right? Something you could only diagnose by talking about it. But what if I told you we could actually see its footprint in the brain? The huge question we're tackling is this: has depression finally become a visible disease? So let's get right into it.
Here's our roadmap. We'll start by looking at how we went from thinking of depression as a mind problem to a brain problem. Then we'll do a quick tour of the specific brain areas that are affected. After that, we'll check out the tech that actually lets us see these changes, and we'll ask the big one: can a scan diagnose depression today? And finally, we'll look at what this all means for the future of mental health.
All right, first up, from mind to brain. This is all about the massive shift in how we understand what depression actually is.
So the old view, which a lot of people still have, is that depression is purely psychological. You can't point to it, you can't measure it. But the new view, which is built on just tons of research, says something completely different. It defines depression as a disorder with real, measurable changes in how the brain works. Now you might be thinking, well, why didn't my CT or MRI scan show anything? That's because those tools show structure. They're like the blueprint of a house. But depression isn't a crack in the foundation, it's more like faulty electrical wiring. It's a functional disorder, and to see that, we needed brand new tools.
So let's get into that anatomy. We're going to zoom right in on the key spots in the brain where this faulty wiring really shows up. First up, let's meet the prefrontal cortex, or the PFC. This is basically the CEO of your brain. It's the part in charge of all the high-level stuff, like making decisions, planning your day, and finding the motivation to actually get things done. Now, in depression, this CEO, well, it kind of goes on vacation. The PFC becomes hypoactive, which is just a fancy way of saying its activity level totally tanks. And this isn't some abstract idea. You can directly connect it to some of the toughest symptoms. That difficulty concentrating, the heavy feeling of having zero motivation, that deep sinking feeling of hopelessness. Yep, that's your underactive PFC at work. Okay, next up is the amygdala. If the PFC is the calm CEO, the amygdala is the brain's supersensitive hair trigger alarm system. It's what processes intense emotions like fear and anxiety, and it's what sticks that powerful emotional punch to our memories. And in depression, we see the complete opposite of the PFC. The amygdala goes into overdrive. It becomes hyperactive. It's like the fire alarm is just stuck on, blaring 24/7. This is what fuels so much of the emotional experience of depression. That endless loop of negative thoughts, those overwhelming feelings of guilt, and that constant humming anxiety. Then we've got the hippocampus. This part of the brain is a real multitasker. It's got two huge jobs. It's our memory maker, creating and filing away new memories, and it's also supposed to be the brake pedal for our body's stress response system. Now, this is where we see just how physically tough depression can be on the brain over time. In chronic cases, the hippocampus can actually shrink. It gets smaller. Why? Because it's constantly being blasted with high levels of the stress hormone cortisol, and that can cause the brain cells there to wither away. This physical change is directly linked to the memory problems so many people with long-term depression report.
So, you're probably wondering, how in the world are scientists able to see all this stuff happening? Let's talk about the incredible tech that gives us this window right into the brain. Okay, here's a super quick breakdown of the three main tools. This is great for exams. First, you have fMRI. It tracks blood flow to see what parts of the brain are working hard. This is how we confirm that sleepy PFC and that overworked amygdala. Then there are PET scans. They track how the brain uses sugar for energy. And in depression, they show the frontal lobes are kind of running on low battery. And finally, the EEG, which listens to the brain's electrical chatter, finds this specific pattern of low activity in the left frontal area, a spot linked to our positive emotions.
So here's a really crucial high-yield concept. It's not just single parts, it's entire networks that get messed up. Your brain's default mode network, that's the part that's active when your mind wanders, it becomes overactive, trapping you in those repeating cycles of negative thoughts, or rumination. At the same time, the cognitive control network, which is supposed to help you break free from those thoughts, is underactive. And the salience network, which helps you decide what's important to pay attention to, gets all out of whack, making it hard to focus on anything but the negative stuff. All this amazing science brings us to a huge, practical question. Can we actually use these scans to diagnose depression in a clinic right now? Let's do a quick reality check. So, the bottom line question is, could you go to your doctor, get a brain scan, and walk out with a definitive diagnosis for depression? And the clear, straight-up answer is no, not yet. The main reason is that the brain patterns we see aren't totally unique to depression. There's a big overlap with other things like anxiety disorders or PTSD. That makes it impossible to rely on just the scan for a diagnosis.
Okay, so a scan can't give a diagnosis. But here's where the story gets really, really cool. Can these scans predict how someone will respond to a specific treatment?
The answer is yes. And honestly, this is a total game changer. Research is showing that activity in one specific area, the anterior cingulate cortex, can help predict whether a person is more likely to get better with antidepressants, or with talk therapy like CBT, or even with newer treatments like TMS. This is the very beginning of personalized psychiatry, moving us away from just trial and error.
So, if you're in med school, get your highlighter out. Here is the one sentence you need to have memorized for your exams. Depression shows functional brain changes detectable on fMRI and PET, but imaging is not yet diagnostic. Got it? Lock that one in.
Okay, let's wrap this up by looking at where all this is headed. The future of psychiatry is being rebuilt from the ground up to be more objective, more personalized, and way more brain-based.
Just imagine a future where AI can analyze these super complex brain scans and find patterns even a human expert might miss. A future where we can match the right person to the right treatment on day one. And maybe, just maybe, a future where we can spot the risk and step in before the symptoms get severe, using objective biomarkers for mental health, just like we use cholesterol levels for heart health. That's the horizon. So, what's the number one thing to take away from all of this? It's simple. Depression is not invisible anymore. We can see its effects, we can measure its impact, and we can treat it. It is a neurobiological disease, and understanding that is the first giant step toward better treatments and less stigma for everyone. If you like this video, then please like, comment, and subscribe.